So the question goes that a light horizontal beam is 15 meter and is supported at the left end and 3 meter from the right end. So let's draw our beam. A light horizontal beam is 15 meter. So let me divide my whole board into two. We have a light horizontal beam of length 15. Just something to represent a beam. The whole length, I'm told, is 115 meter, aka 1,500 centimeter. So this is 15 meter. Now this is being supported and is supported at the end, at the left end, and 3 meter from the right end. So it is being supported. There are pivots at the left end, and then another pivot at 3 meter from the right end. This is the right end. So 3 meter from the right end, we have another pivot over here. So from the end to where this pivot is, we are told it is 3 meter. So it is being supported from the left end and 3 meter from the right end. The beam carries the following point loads. This beam supported at both ends carries the following point loads. 120 Newton, 2 meters from the left. So we have 120 Newton load, which is 2 meters from the left. So from the left, which is this end, we have 120 Newton load. It is 2 meters from the left. So here you have to take your time, listen to the dimensions. Then the next one is that we also have 80 Newton, which is 5 meters from the left hand end. 80 Newton, which is 5 meters from the left hand end. So from the left, I have 80, which is 5 meters from. So if this is 2, then when I add 3 meters to this 2, I locate the 80 Newton load. So from the 120 to the 80 Newton, I have 3. I have 3 meters. Then 90 Newton at the right hand end. So we have 90 Newton at the right hand end. We have this load 90 Newton just at the right hand end of the beam. We are to make a sketch of the beam and clearly show all loads, and that's what we have done. Okay, so if this is 5, this is 8, then it means that from the 80 Newton load to the support, let's label the support as A and B. A and then B. This distance must be, this is 5, 3, giving us 8. Okay, so this distance must be 7.
Yeah.
Please Are we okay with the diagram and the positions of the loads?
Yes, please.
All right. Calculate the reactions of both points of support by taking moment about both supports. Ignore the weight of the beam. So here we have to determine the reactions by taking moment about both supports, where whilst the weight of the beam, we are asked to ignore it. So the reaction produced by A, RA, reaction produced by B, RB. So let's take moment about one of them. So taking moment about A. So we are taking moment about A by ignoring the support B. I must identify clockwise moment and anti-clockwise moment. If I'm taking moment about A, then this will give me a clockwise turning effect. 80 Newton would also give me a clockwise turning effect. Then once I'm taking moment about B, this will also give me anti-clockwise turning effect. Let me clear the physics. So this will give me anti-clockwise turning effect because the turning effect being taken here. So if this force is pointing upward, then when I push the beam upward, it will turn in this direction. Now, the moment the turning effect produced by RA is 0 because there's no perpendicular distance. So let's look for the summation of clockwise moment. Sum of clockwise moments will be equal to 120 Newton times 2 plus 80 Newton times 5. Oh, sorry, we have overlooked another force, the 90 Newton. This will also give us a clockwise moment since we are taking, okay. So 120 times 2 plus 80 times 5, then plus 90 times 3 out. If 3 out, we have times 12. Please, are we okay?
Yeah, do my mede share no.
Vanessa, endum. Okay, so let's sum everything. We have 240 plus 400 plus, what is 12 by 9? 12 by 9.
50.
1,350. 350. So let's sum everything up. 640 plus 1,350.
Mr. Dear.
Hello.
And please, why do you multiply the 90 by 12?
Why did I multiply 90 by 12? You see, we are taking moment about A. Okay. So it is the force times the perpendicular distance from the point of rotation. Okay.
Yes.
I'm
So
coming.
please, why not 10 by 12?
Oh, I'm coming. Yes. Lizzie, you are right. You are right. This is not there. B isn't there. So the perpendicular distance must be 15 rather than 12. Class, are you following it? She asked
Yes.
why we are multiplying why we are multiplying 90 by 12. Okay, the 90 Newton force is at the end, and the perpendicular distance from the force to the pivot must be 15, not 12. Class, are we okay? So
Yes, please.
this must be this must be 90 times the perpendicular distance, which is 3 plus 7, 10, then 5. So it must be 15 rather than 12. If we are using 12, then it's as if we are considering this force, okay, RB times the perpendicular distance. This will rather be 12, but not the 90. Please, are we okay?
Yes, please.
So
No, Mr. D, it's still the same.
90 by 15.
Yes, it's still 1,250.
1,000.
350.
350. Lizzie, thanks
Yes.
for the observation. So sum everything up for me. It's all 1,950.
No, it's 1990. It's the same thing.
1990. Okay.
Please.
Then the anti clockwise movement, even though it is 1, will be equal to RB times the perpendicular distance. And what is the perpendicular distance here? Yes, what's the perpendicular distance?
Mr. D, please, can you bring your camera down a bit?
Yes, what's the perpendicular distance? Lizzie, Adoma, Priscilla, help me. Leon, what's the perpendicular distance here? RB. So
12.
this is 12. Okay, so let's equate this to that. So 12 RB is equal to 1990. Therefore, RB is equal to 1990 on 12, which is, what is 1,990 divided by 12?
165.8.
165.8.
This is Newton. Now, after getting 1, the easiest way out is that, sum of upward forces must balance the sum of downward forces. So RA plus RB must be equal to, this is 290. So if RB is this, then you can easily find RA. Okay, which can be used. But then, you see, the problem with this kind of approach is that in case you got this wrong, in case you got RB wrong and you use this, everything will be wrong. Meanwhile, if you take the moment around the other supports, okay, and then rather use this to check the correctness of your answer. If it doesn't go well, you can see. Class, do you follow what I'm trying to explain?
Yes, please.
So the easy way out is this. You only get this right if the first RB is correct. Now, if along the line you made a mistake, as in what we were actually doing before Lizzie corrected, meaning you have this wrong and using this, you'll get it wrong. Meanwhile, there's no check. There's no check to be sure whether your answers are correct or wrong. So what you need to do is to use the reaction at the other end. When you finish, then you use this to test whether your answers are correct, because when you sum RA and B, it must be equal to 290. If it's not equal, then nobody will tell you that you are wrong. Charlotte.
Yes, please.
I hope you are No comment. Ekweadom, are you here?
Yes, please.
You are Kosiadoma. Ekweadoma. Okay, so let's take the moment around the other one too. Right? Just to be sure. But I think once this is correct, it will be right. But let's use the moment around the other. So taking moments around B, moment. Inshira, you here? Yeah, everybody Inshira. Taking moment around B. So this time around, we are closing our eyes to A, as if A isn't in existence. This is not here. So let's clear our directions, clockwise and anti-clockwise then, because we'll certainly have different directions. So if the turning effect is being taken around B, then this one would give us, what 90 give us clockwise or anti-clockwise? Hello, class, I'm waiting for your feedback. What this will turn clockwise. What about 80 and the 120?
Anti-clockwise.
So this is anti-clockwise. Anti-clockwise. What about RA? Will it be clockwise or anti-clockwise?
Clockwise.
Then what about RB? Would RB be clockwise or anti-clockwise?
None.
0. Okay, so let's sum up all the clockwise movements and then the anti-clockwise movements. So for clockwise movement, we have RA times what? Lizzie, Chrysler, Millicent. RA times
12.
Thank you. Plus 90 times
50.
90 times
8.
3.
90 times 3.
3.
Good. So we have 12 by RA plus 270. Then sum of anti-clockwise movement. Anti-clockwise movement, we have 120 and 80. So 120 times 2 is here, 2 is out, 3 is out. So 10 plus 80 times 5 is out, 3 is out, 7. So we have 1200 plus, what is 8 by 7?
56.
56.
60.
So when you sum this up, you have 1760. So 12 RA plus 270 is equal to 1760. Therefore, 12 RA is 1760 minus 270, which is 1760.
490.
1.
490.
So that when we divide through by 12, We have RA to be equal to
124.17.
124
17.
Now, after deriving or obtaining figures for RA and RB, now you can test that 124.17 plus 165.8 must equal 290. Add these two, let's see. Is it equal to 290?
Yes, please. Approximately 90.
Exactly. So, you see, that is the reason. When you're able to get this right and then this right, then you use the other law to test. And if you are correct, you can see. If you are wrong with your figures, you will see. Yaba, are you okay? Hello, Yaba.
No, please.
Okay. I'm sending one of it to you. An assignment or work which will engage you in about at least 5 minutes. You must finish for me. So I'll send it to the platform. If you have any question.
Is it under this? Is it under moment?
Yes.
Okay.
I want to see how you can quickly apply this under moment. So it is sent to the platform. Let me see how you can quickly do this in about 5 minutes time. It's 2:27. The time starts now. Finished. Class finished. The plank PS is hinged at S against a vertical wall. It is in equilibrium under the action of forces shown in the diagram below. Calculate the force F. So the hinge or the pivot is at S. So let's draw what we have on the given from the diagram. We have the hinge or the support as at S. Then we have a force which isn't directly perpendicular to the bar F. This is inclined at an angle of 30 degrees. Then we have a force of this point is P. This is the point where the force F acts. Then we have a force of 200 Newton at Q. Then a force of this 200 Newton force is 1.5, a distance of 1.5 from the point P where F acts. Then we have another force acting at a point R on the bar. This is 100 Newton. R is at a distance of 0.5 meters from S. So this is 0.5 meters. Then between Q and R, the distance is 1.5. So this is the axis of rotation, the hinge around which turning takes place. Okay. The question is to find F, the force F. Now moment or torque, the turning effect is equal to the force times the perpendicular distance, or the distance times the perpendicular force. One of it must always be perpendicular to the other. Here, the stubborn one is the force. We don't have a perpendicular, or the force F isn't directly perpendicular to the bar PS. So we need to resolve this force to get a component of it which will be perpendicular to the bar PS. And so when we resolve this, we'll have this component which will be the same as what we have here because of equal vectors. So this component, which is equal to this component, will obviously be F sine 30. So we have F sine of 30 degrees. So even though the force is acting at an angle of 30, but this is the component which will cause a turning effect, which will be a clockwise turning effect. So this is the component of the force which will turn the bar around the support S. So we identify the clockwise moment. Let's identify the anti-clockwise moment. This will give us an anti-clockwise moment. This will also give us an anti-clockwise moment. Whereas the vertical component would be the only clockwise moment around the bar. Class, are we okay?
Yes.
Are we okay? Good. So let's equate our clockwise moment to the sum of the anti-clockwise moment. So F sine of 30 times the perpendicular distance, which will be 3.5, must be equal to the sum of the anti-clockwise moment, which is 200 by, this is 2 plus 100 times 0.5, which is half. So this is the clockwise moment. This is the sum of the anti-clockwise moment. In fact, I changed 0.5 to fraction. That is half. Okay. Now, sine 30 is half. So we have 0.5 half times 3.5 is equal to, this is 400 plus 50. Multiply 0.5 by 3.5 for me. What's that? Charlotte. Lizzie, Charlotte, and go multiply
1.75.
what?
1.7.
1.75.
Yes, please.
So when you divide 450 by 1.75, what's your final answer?
257.14.
257.14 Newton
Yes.
is the force. How many of you got this right? How many of you got it? How many of you? Priscilla had it. Who else? Hey, I want more hands. So, Amma got it. Ishira, you got it. Okay. More hands. So, okay. It's a learning thing. So, okay. So, that's it. Any question? Okay, let's try another one. Then we look at when you have non-uniform beam, what happens? Let's try another one. A horizontal uniform rod.
Please, are we to-
Okay. Lauren, I'm listening. Lauren.
Stadia, please, I'm not talking.
Okay. All right. So a horizontal uniform rod of mass
Miss
5.
Lydia,
Hello.
please, are we to write it?
Yes, I'm giving. Yeah, this is a question I'm giving you. So I'll put it down.
Okay.
A horizontal uniform rod of mass 5 kilogram. A horizontal uniform rod of mass 5 kilogram and length 2 meter is supported at each end by wires suspended from a ceiling. A horizontal uniform rod of mass 5 kilogram and length 2 meter is supported at each end by wires suspended from a ceiling. If a mass of 4 kilogram is placed 0.4 meter from one end, if a mass of 4 kilogram is placed 0.4 meter from one end, find the tensions in the wires. Find the tensions in the wires.
Miss Lydia, please, can you go back a bit?
So a horizontal uniform rod of mass 3 kilogram and length 2 meter is supported at each end by wires. Suspended from a ceiling. If a mass of 4 kilograms is placed 0.4 meter from one end. If a mass of 4 kilograms is placed 0.4 meter from one end, find the tensions in the wires. Find the tensions in the wires. This statement is just like the reaction. So apply the same knowledge of solving problems with reactions to do so. Will you give it a try, or you want us to solve it right away? Hello, which is which? Okay, maybe you want to give it a try before I come in. Find the tensions in a string.
Progress.
Okay, let's look at it. All right, so we have a horizontal uniform beam of mass 5 kilogram and length 2 meter. So let's draw a horizontal uniform beam. We are told that the length is 2 meter. So the whole length is 2 meter. Its mass is 5 kilogram. Now, class, if you are told that the mass of the beam is uniform, then what all that it means is that for a uniform beam, we have its mass or weight, which we call as either center of gravity or the center of mass. So that we have either the center of gravity or center of mass acting at the center. What do we mean by center of gravity? Center of gravity is defined as a point within a body where its total weight appears to act. So it is a point within the body of, or it's a point within a body or a particular object where its weight appears to act. Now, if you have a uniform meter rule or uniform beam, okay, once it is a uniform beam, then its center of gravity would act at the center or midpoint. So for a uniform beam, its center of gravity or center of mass, the center of mass of a body is a point where its total mass acts. And once it is a uniform beam, its center of gravity or center of mass would act at the midpoint or the center. Class, are we okay? So note the difference. For a uniform beam or length of something, once it's uniform, its center of gravity or its center of mass would act at the center. Here we are given the mass of the uniform rod to be 5 kilogram. And once it is a uniform one, assuming this is the center, then this is where its mass, center of mass, 5 kilogram would act. So from the end to where its center of mass is, will be 1 meter. Okay, so it is also supported at each end by wires suspended from a ceiling. So it is being supported at each end by wires. The supports are wires to the ceiling. So let's assume this is a point of support. Then there is a wire connecting the other end to the ceiling. So this is another point. Another point. Now, the wires will provide a tensional force. The tension within the wire is always directed to the point of support. So the tension within this wire will be directed to the point of support. So we have T1, a tension 1 in this string, and then T2 representing a tension 2 in the other string. Then, if a mass of 4 kilogram is placed 0.4 meter from one end, choose any end. It can be this end, it can be the other end. We are told that a mass of 4 kilogram is placed 0.4 meter from one end. Okay, from one end. So the one end must be chosen by you. I would want to choose this end. So from this end, at this from a distance of or when I measure a distance of 0.4, I locate a mass of 4 kilograms. So from this point to this point, I have 0.4 meters. As I said, you can also, somebody else can choose this and the choice is yours. Please, are we okay? Are we okay?
Yes.
All right. So this must be the diagram. Now the question is that find the tensions in the wire. Find the tensions in the wire. But Akosia Duma, if this is 0.4, what will be this distance? Akosia, what will be this distance?
0.6.
Thank you. So this will be 0.6. Then what will be this distance?
1.
1. Good. So this is 1 meter. We have to find the tensions. This is similar to we having a uniform bar and then being told that the weight of its weight of 4 kilograms, because a uniform bar would act at the center, 5 kilograms. Then 0.4 meters from the one end, we have a mass of 4 kilograms. Then you've been told that it is pivoted at both ends. It is pivoted at both ends. And so the question is that calculate for the reactions at these ends. Calculate for the reactions at this end. So RA, RB. This is similar. So here, the tensions are the reactions. So start work and then make me proud. Oh, you finished? Yes, I gave you some time to finish. So I think let's take it straight away. So if it is this, you take the moment around one of them. Okay, so let's sort of label this side A, label this side B. So taking moment about A. Taking moment about A. You see, these are also supports. And once it is supported to the ceiling, it means turning effect can take place around any of these. Okay, so taking moment about A, meaning this support seems not to be there. The support B seems to be gone. Okay, so we'll have this, since the support is here, we'll have this giving us anti-clockwise moment. This will give us a clockwise moment. This will also give us another clockwise moment. Of course, the turning effect here is 0. Okay, so sum all the clockwise moments, 4 times 0.4 plus 5 times 1. This must be equal to T1 times 2. So this is 1.6 plus 5 is equal to 2T1. Therefore, you have 2T1 giving us 6.6. T1, therefore, hello?
Why didn't you use the 0.6 meters?
Come again.
Please, why didn't you use the 0.6 meters?
We are taking the moment about A. We are taking the moment about A. That's why this is not here. So if this is not here, we are looking at, this is giving us clockwise, clockwise. So when we take the turning effect of this, we have 0.4, 4 times 4 kilogram times 0.4 plus, this is also giving us another clockwise movement. So 5 times the perpendicular distance. And Lizzie, what's the perpendicular distance from here to A?
It's 1.
Yes, so that's the reason why we added 0.6 to 0.4. Are you okay?
Yes, please.
So we have 3.3 kilograms. In fact, we can also convert this to tension by multiplying this by 10 meters per second squared. And in that case, the tension will be 33 Newton. Okay, but if you leave it as 3.3 kilogram, you are also not wrong. Are we okay?
Yes, please.
Then we take the moment about the other. We bring T2, T1 back. We bring T1 back and then take it around the other one. So this time we assume this is not there. So taking moment about B, taking moment about B, you must clear your directions because this one will give you different directions as well. This will turn in this manner. This will also turn like this. Then T2 will turn in the opposite direction. So we have 2 anti-clockwise moments as against 1 clockwise moment. So we have 2 times T2, 2 times T2 to be equal to 4 times what? Millicent, 4 times what? Yes, Yaba, 4 times what?
1.6.
So 1.6 plus 5 times, Inshira, 5 times. Inshira, 5 times.
1.4.
Inshira, 5 times. You are taking moment about B. So Inshira, 5 times.
1.
1. Okay, so we have 2T2 being equal to what is 1.6 times 4? Eh?
6.4.
6.4 plus 5. So we have 11.4. Therefore, T2 is equal to 11.4 on 2. And what is 11.4 divided by 2?
5.7.
So 5.7 kilogram, which can also be 57 Newton. Now, we do our checks. Total upward forces. So T1 plus T2 must be equal to 4 plus 5, which is 9. Let's see. We had 3.3 for T1. Then we had 5 5.74 T2, which sums up to 9 exactly. And so, hooray! How many of you got this right? How many of you got it? More hands. Okay. More hands. Thank you. Yes. If you never got it, I'm sure you've learned your mistakes. Right? All right. Now, let's look at if we have a non-uniform beam? If the beam isn't uniform, what happens? How do we calculate for what and what? So a question. Are you ready? Are we ready? A question. My people are